You're not going to want to miss this episode of the AI Show where Luis shows us all the new stuff in Azure Cognitive Search, specifically semantic search. Make sure you tune in. Hello and welcome to this episode of the AI Show. We're going to learn all about semantic search. Let me bring this up here so you can see. Finding meaningful insights using semantic capabilities in Azure Cognitive Search. I got a special guest, Luis. Why don't you introduce yourself, my friend?
Thank you, Seth. It's a pleasure to be with you. So my name is Luis Cabrera. I am the Group Program Manager for Azure Cognitive Search. And I've been at Microsoft, like 17 years now. I went there right after college, and I've been having fun at Microsoft ever since.
That's awesome. So let's start first. For those that do not know about regular Azure Cognitive Search, why don't we start with that particular question?
Yeah, that's a great question. So Azure Cognitive Search, think of it as, imagine that you're a developer and you want to create an application where you need to put a search bar out there to find content, whether it's documents or records. Maybe you're creating something for your human resources team, let's say, right? And it's a line of business application. It doesn't matter whether you're creating a web mobile application or a line of business enterprise application. If you have a search bar there, we can power that search with Azure Cognitive Search. It's a platform as a service component. You essentially point us to your information, or you push that information, we index it, then you can query it, and then, of course, we can give you the results, facets, filters. We have a bunch of bells and whistles that are interesting, including one that we're going to talk about today.
So let's move to that. So what's the difference between like semantic search and regular search? I want to understand more about this feature.
No, that's a great question. So with what you call regular search, or we may want to call it keyword search, let's say, right? You usually type some keywords, and then we have indexed your content so that we can quickly find where those keywords are in your content, right? So let's say you search for, I don't know, like let's say a product or something like that, or in Channel 9, right? Let's say in Channel 9, you are searching for the term machine learning, right? So we're going to go and find any place where the terms or keywords machine and learning, and we have language analyzers. So if somewhere else it says learn, let's say instead of learning, we're going to find those documents as well. So we have this, what we call an inverted index. So we can do this very, very quickly. Now, the catch is this. As people have been using search engines like Bing, they are getting used to doing very, very complex queries. So for instance, they may ask a query, how do I learn machine learning? Or how do I do this? Or who is Seth Juarez, right? So when they ask these very complex queries, those have meaning. And it's not about just finding the terms. So imagine that someone is finding who is Seth Juarez, and there are a bunch of other documents that maybe the title of the document is who is Benito Juarez, right? Mm-hmm. That has who is and Juarez. It has three terms that are in common with the query, let's say, right? And maybe Juarez appears all over the place, but it's not the same meaning, right? You're not Benito Juarez, you're Seth Juarez.
That's right.
So how do we find the content that you need, even when maybe you're not using even the exact keywords? For instance, imagine I do a query like, maybe I'm going to a bookstore, and the query is how learn to cook French food, right? So what if the name of the book is called Mastering the Art of Paris Cuisine, right? So I am not using exactly the same words, yet I want to find that book. If there is another book that says how to learn French, even though it uses a lot of the similar terms, that's not the book I want. I want to learn to cook, not to learn a language, right? Mm-hmm. As an example. So this is the problem we're trying to solve. I have a diagram that I want to show you, just so that we can kind of get a little bit deeper into how this works. So we have this lexical ranker. This is what we have, and essentially most of the services out there that do search today, they're based on this type of technology, right? Like lexical rankers. And usually you have a query that goes through this, we find the documents, and then we give you the results. So in our case, sorry, let me put the focus in the right place. Let's say that I have a query, when was Walmart started, right? And I have a corpus of information. In this case, I am going to use a corpus that has 3.2 million documents. It's a big, complex corpus. It's very likely to have a bunch of documents that have similar terms to my query. And by the way, the MS Marco corpus is one that you can play with yourself. It's a publicly available corpus. So it's out there for data scientists to check how good their algorithms are for things like this. So then one of the new things that we added to our product recently, it's not part of semantic specifically, but I wanted to introduce it here because it's part of the process, is a new spell corrector. So if I had mistyped the query, it will have corrected that before going to this lexical ranker. So let's actually run or give you an idea of what it looks like if I run this lexical ranker. So this is the type of documents that I get. Let me see. When I get like results like, when was the WNBA started? When was CARICOM started? When was the Democratic and Republican Party started? So a bunch of documents in this corpus that have when, was, and started in the title. This one is interesting, right? When does Walmart open on Black Friday? It has the term Walmart. I imagine somewhere in there it may say things like Walmart starts its business hours at, I don't know, 7 o'clock in the morning on Saturdays or something like that. But it's not what we need semantically. It turns out that the document that we want is actually in position number 10. So it's there. I mean, I will have found it if I had taken some time to go through all of them and maybe go to the next page in some cases, in some applications, depending on the size of the real estate of the search application. But some people don't have the patience for that. So how do we solve that problem? So we have partnered with Bing, who has developed deep neural network models to help us solve problems like this. They have invested literally millions of dollars and hundreds of dev years trying to solve exactly these types of problems. So we're one Microsoft, and we collaborated with them to use some of their deep learning models. So the first thing that we do is we have a new passage extraction model. Think of it as we take the top documents that are returned from our lexical ranker, such as the BM25 indexer that we have, and then we take those top documents and then we try to identify what are passages here that are representative for this document, right? So if I have a document about what artificial intelligence is, maybe we find a passage that says, oh, okay, so machine learning, is this or that, or deep neural networks mean this or that. So we identify a set of passages from each document. This is extraction, right? We're not generating this. We're actually extracting snippets of text or passages, right? And then we run them through a different model, which is this semantic ranker. So this model takes into consideration the query itself, each of the passages, and essentially is scoring how likely is this passage to be related to the query that was just provided. And then we go and resort the documents again and check this out. Which one is the top document? It is the document that was number 10 in our BM25 ranker before. Ta-da, right? So it came all the way to the top because it understands meaning. It understands that maybe somewhere in there, by the way, this is a pretty big document. It's about 22,000 words. Maybe somewhere in there it says something like Walmart was founded on a particular year or something like that. So it finds that passage, right? And therefore, this gets pulled to the top of the list.
I see. So if I'm understanding this right, and I want to make sure that I do, this is a search engine not for like Bing, but a search engine for my own stuff that I can set up. Is that right?
Absolutely. That's the innovation right here, right? So Bing already has, as I mentioned, invested in creating these models, and they have them in production today. When you go to bing.com, you're essentially using a lot of these models already. The part that is new is that in the past, I mean, they essentially were indexing the World Wide Web, right? And that was great if your content is in the World Wide Web. But what if you have, your own human resources application or a support ticket database that you want to index? Essentially, you want to find information in your own data or your own documents, right? Technical documents, for instance, right? We want you to find the content faster.
That's cool. And so basically that business junk drawer that we all call the share, we can send this service, point it at it, and then what it does, it narrows the search using the standard lexical stuff, but then it re-ranks them semantically. Am I getting this right?
You got it exactly, Seth. Exactly. And there is more. I want to just kind of tell you one more thing.
I do.
So yes, we already solved the problem of ranking, but what if we could give you a little bit more?
Oh.
So imagine we already extracted passages that are important for each of the documents, right? So now we have another model that can extract which of these passages not only are related to the content, but may actually answer the question that you just asked. So by following this, we can actually extract just the passage, right? And in the passage here, it says headquarter invented.
You're saying this like too nicely and too fast. You're saying that if I ask a question, there's a second part of this customized search that will literally find the actual answer too.
Exactly. So we used to give you a list of documents. That was the outcome of Azure Cognitive Search. Now we don't only give you the list of documents, we give you an answer if we find it, of course, right? That will be essentially the passage that is most likely to answer the question that you just asked. And we go one step further, which is we actually can apply a highlighting model to that. So we actually highlight, in this case, the 1962 right here, right? That is within the passage, the elements of that passage that are the most important to answer your question. And we can apply the same capability, just like we extracted answers. We can show you the most relevant passage for each of the documents. That's what we call captions. So we're super excited. I know that you said like, hey, you said this so casually. It's true. Like I said it very casually, but literally we are taking hundreds of years of dead years, I guess, of development. We're taking, a ton of investment that the Bing organization has done. We're taking it and making it available to you. Now, any Azure developer has these capabilities, very easily. We'll talk more about how to do it later. Yeah.
I feel like I want to see it in action. Do you have something you can show us to see it?
Absolutely. Yeah, absolutely. Let's do this. So you were just saying that you were at Ignite and you didn't contract COVID. So we're always worried nowadays, like, do I have COVID? Do I not have COVID? So the other day I had a problem. I had a sore throat essentially, and I was like, holy cow, do I have COVID? And I remember that we had just indexed a bunch of COVID data, for one of our demos. So I figured, okay, so like I'm gonna ask, what are the symptoms of COVID-19? So once again, we had just indexed a bunch of research papers and all kinds of content related to COVID. It's public data that is now available so that researchers can more quickly find answers and solve this problem that is affecting all of us, right? So let me ask this question. So right now what you see is the list of results that we will have returned with our normal BM25 index, this lexical index. So I am going to little by little turn on each of the features. So first I'm gonna fix spelling. I don't think I had too many or any spelling mistakes, but that did have a little bit of impact. I will add the semantic ranking and what? Okay, there we go. Some bug with my demo, and then so you can see that the results kind of got resorted based on that, but it's still like not super clear to me. Like there are the association between age, COVID-19 symptoms, and social distancing in the United States. It seems to be related. this one an ophthalmological update. I'm not sure, right? So I'm gonna add answers and captions so that we can see how each of these documents matter. Check this out. By enabling answers and captions, I find the answer. The World Health Organization identifies fever, tiredness, dry cough, blah, 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 as common symptoms of COVID-19. And it says it lists other symptoms such as shortness of breath, aches and pains, and sore throat. Oh, shoot. That's not good, right? So maybe I have COVID, right? You know, like that was kind of scary when I saw sore throat in the list. So I have the answers, I have the captions, and you can see how like it highlighted some of the areas that may be interesting to sort out, and it helps me kind of triage through the documents faster to see if I want to double click on them. So let's see. So the usual thing that I do if I have a sore throat myself is I just take some ibuprofen and I'm good, right? Like I don't usually get that much sore throat, but usually some ibuprofen or something like that lets me sleep at night and I'm good. But what if ibuprofen is bad if you have COVID? So let's ask another question. Let me see. So okay, so I see. By the way, I see that the World Health Organization is doing stuff. So I'm gonna say WHO for World Health Organization recommendation on ibuprofen. I'm gonna misspell ibuprofen just because I want to show the speller in action. Let's see what happens. And let me see. Let me see ibuprofen. Did I not? I don't know what I'm doing wrong. But should I use ibuprofen?
Yes.
You think I should? Oh, the problem is I didn't say ibuprofen for COVID-19. Otherwise, I don't know if it's okay for COVID-19. Dun, dun, dun. Okay, so look, it says that the medical center in Israel, they monitor use of ibuprofen for a week prior to blah, 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 blah. So that may be an interesting document to look at, right? And by the way, you can see the speller work, right? So I'm gonna use WHO as in like not WHO, but WHO was the first doctor that reported coronavirus. So different use of WHO. And check that out, right? So it understands when I do that, WHO doesn't stand for the World Health Organization anymore, but it tells me the answer. Dr. San Shishian is considered the first doctor to report novel coronavirus, right? So essentially, it says we're moving from just giving you results to using state-of-the-art deep neural networks to give you answers, to help you more quickly triage the records or documents that you care about, thanks to semantic search.
That's amazing. So I'm guessing that you probably have to set up an indexer and point it at something. I don't want to see that. What I'd like to see, if possible, is how do you use the service once you've set it up properly? Can you show us that?
Yeah, that's a great question. So our service is platform as a service. So essentially, you have a REST API that you use to query the service. So I'm gonna use an extension that is essentially hitting my service. I just have to tell it what the request is like.
Okay.
So this is a visual. By the way, I want to advertise it a little bit. It's a nice tool. It's this VS Code extension for Azure Cognitive Search. All I did is install the extension, select my service, go to a specific index, and then I can essentially make queries out of it. So I had this kind of document, this index based on oil and gas documents right here, and I just want to show you like this is what a simple query may be like keyword search essentially, right? So I'm gonna click Control Alt and R at the same time. Oh, sorry, I think I have a typo in my JSON somewhere. Is that right? Do you see it right away? If not, okay, no. So I don't know what it was. So ignore this error here. So I did this query, and you can see that I get some results. These are some documents from the Society of Petroleum Engineers and so forth, right? That's great. I can learn about profiles, but I'm going to go one step further. I am going to change, add a few fields. Essentially, you can see the fields right here. Let me just zoom into them. I can essentially just specify the search fields. And the reason the search fields are important is because those are the fields that will be used to extract the snippets, essentially the passages, so that we can do the semantic ranking. Provide the language, because like different languages may have different semantic meaning given the query that I do. If I want to use a speller, I will specify the speller as well. And I can tell it if I want answers or not. In this case, I want extractive answers, and what fields I want to select, and so forth. I'm gonna do a harder query. I'm gonna use exactly the same, but I'm gonna say how to estimate injection profile, which is really what I wanted to know. So once again, I select this and then Control-Alt-R. And you see on the right, by the way, this is the JSON that comes back. Now we have this new component called search.answers, which is what was powering that answer that you were seeing in the other UI.
That's cool.
And what is really nice, I mean, I have the result injection profile was estimated, like some complex stuff that they were doing there, but it's giving me the answers. The results are now, if I look at the value of the results, now they have this re-ranker score, that this is the semantic score coming back and being resorted by this semantic score. And obviously I have the any captions or highlights that I may want for the particular document. So the key point here, Seth, is I didn't have to reindex any content. I didn't have to essentially spend hours reading the documents again. This is happening in real time. And if you have an index already, essentially you just change 4 lines of code, 5 lines of code, and magic happens, right? Now you have semantic answers, semantic captions, semantic ranking.
So if someone's already using Azure Cognitive Search and they've already pointed at their documents, they've got a really good indexer going, and there's an index that they have, literally they can just turn these things on if they want right now.
Yeah, exactly. With one caveat, which is this is a preview, and it's a gated preview. So you have to fill a form to join the preview, and we will approve it. We're approving that, this is completely new, so we want to make sure that we have a way to connect with you as you are trying this for the first time, and you provide us feedback at the very beginning.
So this is amazing. Where can people go to find out more?
Okay, so there is there are 2 links. Or the preview is aka.ms/semantic preview.
Okay.
And that will take you to the form that I was referring to, where you can essentially, here, let me just put it on the screen, because
let's do that.
Let's do this. I think I have there you go. aka.ms semantic preview. Can you still see my screen, Seth?
Sure can.
Okay, perfect. So that is the most important link. I believe you also created an aka.ms/semantic that takes you to our Azure Cognitive Search Azure page, where you can learn about not only semantic search, but all the other features that we have to offer.
That is correct. Well, this has been amazing, Luis. And then make sure you look at the other camera.
Oh, this is the camera. Yeah, sorry about that. So I was probably looking that way most of the time, but hey, please try semantic preview. We're excited about it.
Awesome. Well, thanks so much for spending some time with us, and thanks so much for watching. We're learning all about, that's right, finding meaningful insights using semantic capabilities in Azure Cognitive Search. This has been another episode of the AI Show. Thank you so much for watching, and hopefully we will see you next time. Take care.
Thank you.